Now we are in lesson 5.3. As I said in the preceding video that we're going to have an example more detailed in this lesson to be able to learn more about the quartiles. So first part in this lesson is how we're going to do the box and whisker diagrams. We call it also the box plot. To be able to do the box and whisker diagram, we need to have to include 5 values in this diagram. We need to have the minimum value, the first quartile, the median or the second quartile, the third quartile, and the maximum. To be able to do that, let's do an example, guys. I have this tables of the height of the basketball players. If I look at the first line, those are the height of the basketball players. I have 160, 177, and for each height I have a frequency. So I have one player here, 2, 1, 1, 1, 2, and I can see my total is 10. Okay, I can find the cumulative frequency. It's 1, then I take 1 plus 2, 3, 3 plus 1, 4, 4 plus 1, 5, 6, and then that's it. If you look at the range of these values, the range is 205 minus 160, and it's 45 centimeters. And I can notice that it's a really large range. And I have a big difference between the tallest and the shortest. So maybe we have outliers. So we need to use another interpretation or another method to study this case here. Okay, so what we're gonna do, we're gonna do the interquartiles to be able to study this table. So first of all, I need to find the minimum. The minimum is 160 and the maximum is 205. Now I need to find, I still have the median, first quartile and second quartile, and third quartile. Here should be Q3, not Q2. Here should be Q3. This one should be Q3. Okay, I'll fix it. Now, the median, what's gonna be the median? If I have 10, here it's even. It means the median will be the average of the fifth and the sixth, because it's 10 over 2, 5 and the 6. So the fifth and the sixth value, if you want to look at it, the best way to look at it is to look at the cumulative frequency. This is the fifth and this is the sixth value. So it's 180 plus 182 over 2. So it's 181. I'm going to find the first quartile is n plus 1 over 4. It means it's 2.75. It means it's the third height. So what is the third height? It's here. Because here I have 1 and here I have 2. 2 plus 1, 3. So this is the third height. That's 177. And if I want to find the third quartile, Q3, it's 3 times n plus 1 over 4. So it will be the eighth value. It means it's 185. I want to look at the at the table here. So that's it. The 8 is here. So it's 185. Okay, then we have the values. Now we're going to put, and then we're going to find the interquartile. It's Q3 minus Q1. I don't know why it's written wrong here. I'm sorry, guys. It's Q3 minus Q1. So it's 185. So it's 8. Excellent. Now I need to do the box and whisker diagram. So what we need to do now is, I have all those values, I need to put it in order. So I have the smallest is 160, and then 177. This is the distance approximately between them. Then 181, 185, and 205 is really large here. And then I can join here, and this is my box. Now I'm gonna check if there is outliers. To check if there is outliers, you multiply 1.5 times the IQR, and it's 12. What does it mean? It means that I can have a minimum value 12 below 177. So this is 177. This is the lower, the first quartile. You subtract it by 12. It means the minimum value that you can have is 165. Any value less than 165 is an outlier. So if you look at the board, which one is less than 165? It's just 160. So I have the first outlier is 160. Now let's see if I have another outlier. So I can have a maximum value 12 above 185. So the maximum that I can have is 197. So I have another outlier. What is my other outlier? It's 205. So that's it. It's very simple and very easy. And this is what I was talking about in the preceding video. Now, unbiased estimator for the population. For the population, I can predict if I want to predict what's going to happen to this population. So I have those two formulas. So we use it if we have a sample and we want to predict about the population. We're going to do an example, and that's it. So let's say I have a machine produces 1,000 marbles each day with a mean diameter of 1 centimeter. A sample of 8 marbles was taken from the production line, and the diameters measured the result in centimeter were. So those are the diameters. If you see here, look, 1.1 point it's written twice. So that's why here we don't multiply it, but look at the x bar. They just added over 8. So if I want to translate the formula here, I'll just write sigma xi over n. I didn't multiply it by the frequency. But normally, for example, you can write it's 1 times 2, 1.1 times 2, and then you add them. I got x bar. Then I will find x minus x bar and then minus x bar squared. I will do the formula, and what's going to be what the standard of the machine would be for the whole day. So this is my prediction for the standard deviation. That's it, guys, in this lesson. It's very simple. Sure, we're gonna do more application in the class. See you in the next video.